This will be for the con exercise, general triangle word problems. So you need to use the formulas for the law of sines and the law of cosines. Okay, the formula for the law of sines is pretty simple, and you're only going to use 2 of these at a time. And of course, you can take the reciprocal of all 3 and it'll still be the same formula. All right, you want to remember that capital letters A, B, and C, those represent the angle measures, and lowercase a, b, and c represent the side lengths. All right, for the law of cosines, it appears like there are 3 separate formulas, okay, but these are basically all the same, and you can always change the lettering on the vertices or the points and adjust them to fit one of these formulas. So you can use any of these 3, but if you're into memorizing formulas, I would only try to memorize this one right here. Okay, and the only thing is the angle that you need to be given when you use law of cosines, they label that angle C. Okay, but really you can, whatever angle you're given, you can just change that to angle C if you want to, and then change the respective side lengths. Of course, you want to remember that angle A is across from side length A. Angle B is across from side length B. And angle C is across from side length C. Okay, so make sure you label your triangle as such. The other thing that you want to remember is that the sine of theta equals the sine of 180 minus theta. Okay, so if your angle or answer for the angle doesn't make sense, you're going to want to subtract it from 180 degrees, and it could be either one of those answers depending on whether or not they tell you if the angle is acute or obtuse. All right, you can read the write-up on these, but I don't think they matter because they give you a diagram. Anyhow, Dennis, Vera, and Yash are rock climbers. Yash is connected to Vera by a 30-meter rope, which is taut. That means there's no slack in the rope. Okay, and Vera is connected to Dennis by a 25-meter rope, which is also taut. Yash has already completed the climb, and he takes out a camera to take a picture of his friends. Dennis sees an angle of 41 degrees between Vera and Yash as shown. All right, so that's right here. What is the minimum camera view angle Yash can use to see both of them? Do not round during calculations. Round your final answer to the nearest degree. Okay, so we can see this angle right here is represented by a question mark. Now, law of sines is easier. So I try to use law of sines first. And then if not, then I'll go to the law of cosines. So law of sines is just sine of an angle A over A equals sine of an angle B over B equals sine of an angle C over C. Okay, now we're not using 3 at a time, we're only using 2 at a time, so I'll cross one off. So in order to solve this one equation, we can only have one unknown, so we either need 2 angles in one side or 2 sides in one angle, and we do have that. We have 2 sides and we have 1 angle, so we're good on that. Now, since I chose A and B and I crossed off C, we're going to label the sides A and B. So I'll let the 30 meters equal A. I'll let the 25 meters equal B. And now you have to go across. All right. Across from side length A, that has to be angle A. So I'm going to make this point A right here. And across from side length B, that has to be angle B. Okay, remember the angles are the capital letters, and the side lengths are the lowercase letters. So make sure you line them up. And now we can just plug in. Okay, sine of A, and we see angle A right here is 41 degrees. So that's going to be the sine of 41 degrees divided by side length A, which we said was 30. And that equals sine of B. We don't have B, so I'm just going to leave it as sine of B. You can plug in the question mark if you want, but we know at this point the question mark is B. And side length B is going to be 25. Okay, we're trying to isolate B. This is divided by 25. The opposite of dividing by 25 is times 25. So I'm going to do that to both sides. All right, on the right-hand side, 25 over 25 cancels. Now we want to isolate B. The way to get rid of sine is to take the inverse sine of both sides of this equation, okay? It looks like sine to the -1, but that's not an exponent, that's inverse sine. And we need to do inverse sine of this whole thing on the left-hand side. Inverse sine of this whole thing. On the right, inverse sine and sine drop out, and we are solving for B. So let's evaluate this whole thing first, and then take the inverse sine of that number. Okay, we had 25 times sine of 41, close parentheses, divided by, well, I'll do the divided by in a minute. Okay, 25 times sine of 41, hit equals, divided by 30. Actually, make sure this is in degrees first, because we're using degrees. It's in boldface. I'll try again. 25 times sine of 41, close parentheses. Click equals, and that whole thing was divided by 30. Click equals. Okay, and we're taking the inverse sine of that number. So this is INV, inverse sine, and ANS is the previous answer, inverse sine of the previous answer. Okay, and we're rounding off to the nearest degree, they said, at the very end. So if that is less than 5, you round it down, and it's just 33. All right, so this right here is just 33 degrees. Does the answer make sense? Well, I think so, because this looks like it's at least 90. Okay, we know the angles inside of a triangle have to add up to 180. All right, we did say at the beginning, the sine of theta equals the sine of 180 minus theta. All right, now this is the angle theta here. If we did 180 minus theta, that is 147 degrees. Is that what that looks like? Absolutely not. Okay, so I'm going to stick with the 33. All right, so nearest degree, 33. All right, satellites have spotted a UFO. Scientists want to determine its distance so they can later determine size. The distance between the satellites is 900 kilometers. From one satellite's perspective, the angle is 60, and the other angle is 75. All right, so they give you the diagram. The write-up isn't that relevant, isn't that necessary. How far is the UFO from KA-12? Do not round. Round your final answer to the nearest 10 kilometers. All right, let's see. So, I always go for law of sines first because that one is easier. So instead of writing all three this time, I'm just going to write two of them. Sine of A over A equals sine of B over B. All right, we need at least two angles in one side or two sides in one angle. And we do have two angles in one side. All right, so we're good on that. Now let's see. We want the side lengths across from the angles. So since we have two side lengths, I will let this side equal A, and I will let this side equal B. All right, and now we just go across. Across from A, that has to be capital A. Across from B, I'm sorry, we're going side to angle, not side to side. Side to angle. Across from B, that has to be angle B. Okay? Now, you're probably saying, well, if we need this angle and it's missing, how are we going to use that? Well, we do have two angles, so we can easily find the third. Recall that the angles inside of a triangle add up to 180. So we just have to subtract these two from 180. So this angle here is simply 180 minus 60 minus 75. All right, so that's going to be 120 minus 75. That's going to be 45. Okay, if you want to double check, add these two. That's 120 plus 60. That's 180. So we're in business. All right, I don't have much room. I'm going to fill this in by erasing. All right, so sine of A, our angle A is 75. So I'm going to erase the A and fill in a 75 right here. Okay, sine of B, that's angle B, that's 45. So I'm going to fill in 45 right there. Erase the B and fill in a 45. Side length A, we do not know. I'm just going to leave it. Side length B is 900. So in place of the B, I am going to write 900. Okay. Now, they asked us for this answer in kilometers. So I'm going to leave the units off. Since this one is in kilometers, when we solve for A, it will also be in kilometers. All right. So we just have to do this here. All right, let's see. I think the easiest is just to cross multiply. Okay, A times sine of 45. So we have A times sine of 45 is going to equal 900 times sine of 75. So that's 900 times sine of 75. All right. Solving for A, the opposite of times sine of 45 is divided by sine of 45. So I'm going to do that to both sides. All right. Let me clean this up. All right. We did A times sine of 45. And that's going to be 900 times sine of 75. All right, solving for A, the opposite of times sine of 45 is divided by sine of 45. All right, sine of 45 over itself cancels, and we're solving for A. This is on the calculator, set to degrees. All right, 900 times sine of 75. Close parentheses, click equals, divided by sine of 45. Close parentheses, click equals. All right, and we are set to degrees, and we got 1229. Okay, I think they said the nearest 10 kilometers. So 1229 is going to become 1230. That's the nearest 10 kilometers. Okay, so right in the box, it's just 1230. Okay, does that answer make sense? Well, this side length is 900, so I could see this one being 1230. All right, this time I won't read the write-up. They want to know the length of the tunnel to the nearest tenth of a kilometer. Do not round during your calculations. All right, so obviously this is the length of the tunnel right here. Now, we cannot use law of sines because for that one, let me see. If we use the law of sines, we don't have these respective angles here. We don't have this angle across from that side or this angle across from that side. So we need to use law of cosines. Okay, and that's going to be c squared equals a squared plus b squared minus 2ab cosine of c. All right. Notice it starts like the Pythagorean theorem, so that's how I remember it. Anyhow, the one angle we do need has to be labeled C because we're taking the cosine of that angle. There's no other trig functions in here. So the angle has to be C. So since this is the only angle given, that point has to be C. All right. And now as far as A and B, it doesn't matter which is which. So if this side length is lowercase a, and you go across, this angle or vertice has to be capital A. If this side length is b, lowercase b, going across to the angle, that angle or vertice has to be capital B. All right, so now we're in business. We're basically, oh yeah, and since we labeled A and B side lengths, the tunnel side length is just going to be little c, lowercase c. So there you go. C is across from C, A is across from A. They all match up. All right, so little c, we don't know. So we're going to keep that as c squared. A squared is going to be 7 squared. B squared is going to be 6 squared. Minus 2 times A, which is 7, times B, which is 6. Okay, times the cosine of C. And angle C is 29 degrees. So this is all calculator work. And then we have to take the square root at the end because we're solving for C squared. Make sure you're set 2 degrees. All right, so we have 7 squared. Let me see, 7. There's the squared button. 7 squared plus 6 squared. So it's inverse square root on this calculator to get it squared. Minus 2 times 7 times 6. And then times the cosine of 29. Close parentheses. Make sure it's on degrees. You click equals. Now that answer is C squared. The way to solve for C is to take the square root of both sides. All right, so taking the square root of C squared will give you C, and that's going to be the square root of this number right here. So I'm just going to take my answer, leave it there, and click the square root button, and ANS is the previous answer. So it's just the square root of the answer. Click equals. Okay, I think they said nearest tenth. So you look at the second decimal. If it's 5 or more, you round up. 3.3 is going to become 3.4. All right, so right here, 3.4. And they did say nearest tenth. Does the answer make sense? Well, this side length is 6. So I could see this shorter side length being 3.4. This one here is 7. It makes sense.